Okay. Zeros of a quadratic function. They use something called the discriminant when looking at something in standard form. The discriminant formula is d is equal to b squared minus 4ac. D, not particularly being an important number, just the values of it that are important. If d is greater than 0, okay, then we have two zeros, or also known as zeros are also the x-intercepts. Okay? If d is equal to 0, we have 1, 0, also known as x-intercepts. I'll just quote those. And finally, if d is less than 0, we have 0 zeros or 0 x-intercepts is what they're trying to tell you. Okay? This discriminant only works when we're in standard form. So we'll quickly do 3 quick questions. We have a standard form, then we can do a vertex form, and even a factor form. The factor form is a little easier to work with. Okay, so let's go to the whole page. They've given us an equation. We'll do the standard form one first so we can use the discriminant. They have 3x squared minus x plus 5. Yeah, perfect. Y equals, we'll say. Okay, well, in our standard form, when they talk about A, B, and C, I looked at this one. I decided. It's the same thing. It's not a big deal. Our A value, our B value, and our C value are right here. Okay? Well, our C value is 5, our B value is -1 in this case, and our A value happens to be 3. Okay? So when we go to use the discriminant, D equals B squared minus 4AC, we plug these values in. Well, our B happens to be -1 squared minus 4, A is 3, and C is positive 5.
Oh, no, I'm looking at that part.
Is this okay? So 1 squared gives us 1. -4 times 3 gives us -12. Times 5 is -60. So our discriminant is -59. With that number, what information do we know?
That it is greater than 0.
Well, actually,
wait, no, it's less than 0.
Less than 0. So how many x-intercepts or zeros are there?
0.
0. So what they're saying is if we have a parabola like this, they have something that maybe looks like this. Okay? In fact, it does. This one's A positive, so it opens up. The vertex is above the x-axis, so there's no x-intercepts in this question. If they happen to have been, and we'll show little examples beside these, for 2 zeros, what they mean by that is something that either goes like this. See how it goes through it twice there? Or maybe facing downwards, it goes through it twice this way. 1 0, so if the discriminant is 0, means it's tangent. The vertex is tangent. Okay? So it's just touching. So the vertex is on the x-axis, or like this. And then finally, the last option is what I drew you below, and we'll draw it again just to make sure. Where maybe we have it's above like this, or it could be below and the vertex is below the x-axis. Those are options for no zeros. So these are what the parabolas essentially look like when we're talking about zeros. Now, the reason the discriminant formula is important is it comes straight out of the quadratic formula. And I'll talk about that. Quadratic formula, if you remember, is x is equal to, right, minus b plus or minus square root of b squared minus 4ac 2a. Okay, where's the discriminant directly from? Can you see?
The square root part?
Yeah, it's right underneath that. The reason being is the square root's what really tells us how many zeros we have. The reason being is, let's think about this, okay? If I have a positive number, so greater than 0, so 1, can I find the square root of 1, positive 1?
Wait, yeah.
Yeah, I can. It'll be some decimal. Or I can find the square root of 2, 3, 4, any of those numbers. And we're going to get a positive and negative version, which means this comes into play, the plus and minus, and we'll have to split this. In other words, getting 2 answers, right? So if underneath these brackets is positive, we know we're going to have 2 zeros. So we're going to have to split it and find 2 x-intercepts. If the number underneath this happens to be, looks like that, a 0, what's the square root of 0?
0.
0. So this part cancels out, and we're just left with whatever term b is divided by 2a. So we're only going to get one x-intercept because this canceled out. So we're only going to get one x-intercept. In other words, the vertex is directly on the x-axis. And finally, if this is a negative term, can I find the square root of a negative term?
Yeah, you can.
If I have negative 20 or 21, let's say, can I find the square root of negative 21? If we're using I, yeah, okay, but we're not using it in this instance, okay?
No.
So without irrational numbers, we can't find that, right? So without an irrational number, we can't find that square root, so, oops, what it's saying is there are no x-intercepts because we can't square root that term, okay? So that's the idea behind the discriminant formula. Two other ways we can quickly solve this. That was in standard form, okay? Let's go to vertex form. There's a vertex form example, which is pretty simple. In vertex form, you just got to be able to recognize how to graph something very quickly. Plus 4, okay? Well, let's quickly graph this. We don't even really need the points. I can just estimate this graph. There are two major things. Remember, this tells us the x value of the vertex. It's going to be at positive 2, okay? And the y value of the vertex, sorry, is going to be at positive 4. So positive 2, positive 4. My vertex is here. Okay, here's my 4. And our A is positive or negative?
Negative.
So which way is it open?
Down.
Down. So from the vertex it goes down. How many x-intercepts are we going to have? How many times will it cross the x-axis?
Once.
Is it only once?
Well, twice.
Twice. So that means in this case we have 2 zeros. All right. We don't even have to get the exact points. We just know if they're asking us how many zeros, if the vertex is above and it's opening downwards, it has to have 2 x-intercepts. It's simple as that. Okay. Factored form essentially is giving you the x-intercepts. When you're in factored form, so that's vertex form, how to find how many zeros. And in factored form,
So is it the same thing when it's pointing up to?
well, if this had been positive, let's say, okay, I'm going to erase that because I don't want to get it confused. But let's just say it had been positive 3, exact same numbers, okay? We would have had, okay, say it was like that. We would have had this going up. How many zeros would the blue one have?
Oh, none.
None. So see how important the direction of A is? A tells us whether we're going to have 2 or none, okay?
So like the A, is it, wait, so the 4 determines if it's going up or down, as in like moving
Yeah,
up?
moving the vertex up or down, yeah. Yeah, and the A tells us which way it opens. And finally, a factored form question. The factored form question is written something like this. Y equals 5, x plus 4, x minus 2. Well, we can easily find the x-intercepts by setting this equal to 0 and then splitting this question, right? We know we can find our zeros. 0 equals 5, x plus 4, x minus 2. Well, we want to isolate the brackets, so we're going to divide both sides by 5. Okay, what's 0 divided by 5?
0.
Yep. So a 5 essentially goes away. Okay, so we get 0 equals x plus 4, x minus 2. Well, we know for a fact that there's going to be 2 answers here. When x plus 4 equals 0, right? And we can actually find them very quickly. That's x plus 4, and their other option is when 0 is equal to x minus 2. Well, we actually found what they were in this case. X is negative 4, and x is positive 2. Okay? So in other words, there are 2 zeros to this question.
So for that one, the sign that just answered?
Yeah, the sign just gets switched inside because we set it equal to 0.